All right, you may be still writing, and that's fine. It tells us scientific notation. Scientific notation is where we use exponents to make it easier to work with very small or very large numbers. It will be written as a product of two factors. Their first factor should be a number greater than or equal to 1, or in other words, a single digit. And then that second factor will be a power of 10. 10 will always be the base. It then told us if placed in a calculator, it will be represented with a E. And I gave us an example. 3 times 10 to the 4. We put that in the calculator, we may see 3E4, which is still the same as saying 3 times 10 to the 4. All right, at the bottom, I gave us some steps on how we would move numbers in scientific notation. All right, ladies, I thought I made the correction last week with 1230. All right, so our first step tells us we're going to shift the decimal to get a single digit in the front. The second step will tell us we're going to rewrite, including all those digits that'll be before or after the decimal. The third step, we're going to pay attention to the number of shifts, and that will be our exponent. And then, of course, we pay attention to how did we shift. If we shifted left, we will have a positive exponent, and if we shifted right, we will have a negative exponent. Scientific notation.
McKenzie, I'm still writing.
Let me know when you're ready, Kennedy, and some of the others.
McKenzie, I'm finished.
I'm still writing.
All right, let me know when you're ready, Makeda.
I'm done.
All right, I'll take it you the last one. No one else said. All right, so now let's do some exploring. This is our first example. They gave us 1,850,000, and they want us to put that in scientific notation. You all know me, I'm pretty procedural. So that first step told us we would shift to get one digit behind the decimal. Now notice it's a large number. So any large number that don't have a decimal, the decimal will go at the end. We're gonna place the decimal at the end, and we're gonna shift till we get one digit. All right, and that one digit will be 1. So that decimal will be 1.85. So definitely make sure you get the digits after the decimal as well. And then we're gonna put that times 10, and then count how many times we moved. And in this instance, it would be 6. And it's a positive exponent because this is a very large number. Very large numbers have positive exponents. Any questions? All right. Some talking and saying no. Shake your head or so. We good? Okie dokie. All right, second example. It says, write this number in scientific notation. Once again, we'll repeat the same process. However, at this number, we should recognize that it doesn't have a whole number. So any number that starts with 0 in front of the decimal is very small. Anytime there's a 0, add the whole number. But then we'll repeat that same process. We'll start at the decimal and we'll go until we get one digit in front of the decimal, which will be at the end. So the number will be 7 times 10, and this time it will have a negative exponent because it is a very small number. Any questions about what we're doing?
No, ma'am.
All righty. All right, I'm gonna give you about 30 seconds to a minute. See if you can write this number in scientific notation based on your steps. All right, who want to give it a shot?
Me,
Go ahead, Jamal.
it's a very big number because it's a high number and you don't write it. Hold up, let me get my note. You don't write it 597, 990. Oh, time how many zeros he is.
So Jamal gave us 5,974, and then he said times however many zeros there are. Someone else want to give it a shot?
It's 21 zeros.
21 zeros? But did I mention count the zeros?
No.
How many places you move?
All right, so count all the numbers after you place the decimal. But first we gotta place the decimal. Kenny told us there were 21 zeros, so we gotta keep that number in mind. All right, so where would the decimal go?
Between
Where
the
the
5
five
and the
at?
9.
All right, good job. It'll go between the 5 and the 9. So 5.974, and we know it'd be times 10 to the something. What I love about large numbers is that every comma grouping has 3 numbers. So you can kind of use your multiples of 3 to help you determine how many. So that'll be 3, 6, 9, 12, 15, 18, 21. And we still have to count these 3 because they're behind the decimal. So that will get us to 24. Any questions about it?
No, ma'am.
All right, does everybody understand what's going on?
Yes, ma'am.
All righty. Place that decimal behind that first digit. Count how many times we would have shifted over. And if you needed to do your shifts to get there, you can still do your shifts and help you with your count. If you can't think of multiples of 3, but you still should have ended up with 24. Good job, ladies and gents. All right, I love how some of us meeting that expectation this afternoon. Good job to you. All right, this one said use the information in the table to solve the problem. I'm gonna give you about a minute to see if you can write these 4 values in scientific notation. Think about what we just did with this last problem. Give you about a minute. All right. Destiny Nicholson, can you help us write mercury in scientific notation?
S
You muted.
I am
Mitchell,
3.63 times 10 to the 7th power.
all right. Place the decimal with 3 in the front. She said 7. Good job. That will be correct. All right, Mars. Who want to help us out with Mars?
$1.42.
All right, and what's our X mark?
8.
10 to the 8th power.
3, 6, 7, 8. Okay, it works. All right, somebody different. Help us out with Neptune.
367. No, 3.67 times 10. 1, 2, 3, 4, 5, 6, 7, 8. 8 decimals.
All right. You missed one, but I love it. 3.67 times 10 to the 9. And he gave us Pluto. All right, somebody else was unmuted. You want to give us that Neptune?
9. 2.8 times 10 to the 9th power.
Good job. Good job. So it looks like most of us understand what is going on. Good job to you. All right, at the bottom it said Neptune is about how many times as far from the sun as Mars? They said Neptune is about how many times as far from the sun as Mars? All right, so this is Mars and this is Neptune. I'm gonna box in that piece right there. So they went from 142 to 2,800. 142 to 2,800. About how many times would that be? All right, let me ask you this. How many extra zeros are added?
One more than the other.
There's one more than the other one, so we know that's at least 10 times, right?
Yeah.
Yes.
So that's at least 10 times, and then we count that. Let me break it down smaller. We ain't gonna look at it with this big value because you can't do the big value. Let's do small. So what if I separated it right there? 14 to 280. Or in other words, 14 times what number gonna get us to 28?
2,
14 times, what number is 28?
2.
2,
Good job. 2, and somebody said it had 1 extra 0, so that would make it about 20 times larger. It will make it about 20 times larger.
It's 20 times farther than the sun. Why you say larger?
Yeah, we can use the term far. Yes. Far from sun. Good job, Jamal. Yes, we can do that. All right, I'm gonna give you about 30 seconds to a minute. Read it and see if you can help us find the correct scientific notation.
I know it.
All right, what you got, Jamal?
It's not A
Why you say it's not A?
because it's not a negative number.
Good job. Before you move on, Jamal, let me state something. That negative exponent will not make that number negative. All right, you can go ahead, Jamal.
It's not B because it's not no small number. Small numbers have zeros before it.
Okay.
And you can eliminate C2.
Before we start eliminating C and D, have another look at your exponent. Now we said exponent of negative go to a very small or very large number.
a very small number.
Well,
So we can eliminate D.
Good job. Good job. So the correct answer, Jamal, would actually be that C. And if you look at it this way, it does have the 0 in the front. Good job. So definitely make sure we understand that that negative exponent does not change the value to negative, and then have another look and make sure that it's a big number or a small number. Now they said Eva chose D. How did she end up with D?
So she did what I was about to do. Straight ahead.
You are correct. She ignored the negative and she shifted the other direction. So definitely make sure you pay attention to that, Jamal. Good job. Good job, ladies. Joining in and helping them out. Any questions about it?
No, ma'am.
Y'all don't like talking to us, you can shake your head or something. Let us know we on good standing. All right, have a look at this one. I'm gonna give you about 30 seconds to a minute. All right, it reads, Carol was using her calculator to solve a problem. The answer that displayed was 1.6 E plus 12. She knows that she entered all the numbers correctly. Why did the calculator give the answer it did? Why y'all think the calculator did this?
It was too big. It mean herb.
And just remember, a calculator screen only shows about 9 to 10 numbers. A calculator screen only shows about 9 to 10 numbers. So when we get those with those large exponents, 24 or 10 and above, they're gonna have to cut that off and just put the E with it. They then asked her, what is the answer to her problem? So how else will we rewrite what that calculator gave her?
She could have said, did it like we did, stand putting all of the zeros in it. She could have picked the first digit of the number, then time it by 10.
All right, and what's the exponent? That's any of you. What's the exponent? All right, so if we look at that calculator, I need somebody. It'll be 12. And so that's what I was stating. The decimal in the front will tell us what decimal will be the first product. That E represents times 10. And then what's behind the E will be your exponent. And they try to remind you to let you know if it'll be positive or negative. But some calculators won't put a positive sign if it's positive. They'll just put the negative if it was negative. So if you have a problem like that, just remember the front is the first decimal. For E, put times 10, and then what's behind the E will be the exponent. Good job. All right, I'm gonna give you about 30 seconds to a minute. All right, they want us to put this number in scientific notation. Put this number in scientific notation. Faith, you over there? Can you put this in scientific notation for us?
I think it's B.
All right, why you think it's B?
It has 2 zeros. Like,
And plus, we have numbers behind the decimals.
All right, so she noted it got 2 zeros. Jamal came and told us they had some other numbers behind that decimal. And overall, we got 6 numbers behind the decimal. All right, did everybody agree with Faith and Jamal?
Yes.
Yes.
Yeah.
Yes.
Good job. All right, I'm gonna give you about 30 seconds to a minute. See if you can read and attempt to solve this problem. All right, now this problem threw in some comparison. It says the average distance from Pluto to the sun is about 6 times 10 to the 9 kilometers. The average distance from Mars to the sun is 2 times 10 to the 8 kilometers. The average distance from Pluto to the sun is about how many times as great as the average distance from Mars to the sun? So sometimes when they give us numbers that we are comparing, it'll be best to just go ahead and write those values out. Case in point. 6 times 10 to the 9. 6, and we know we would shift 9 times right. Go back and add zeros. All right, so that would be 6 billion. And then we got 2 times 10 to the 8. The same process will occur. 1, 2, 3, 4, 5, 6, 7, 8. And just remember, when they give us a whole number, the exponent will tell us how many zeros to add. Only when it's a whole number. If it's a decimal, you still gonna have to count. All right, so we got 200 million and then 6 billion. How many 200 millions can I get in 6 billion?
4.
All right, I hear 4. Anybody else?
4 to the 10th power.
You could tell it's 4 because if you do 2 times, wait, no, it's 3.
All right, and let me separate it for you. This didn't have that third piece, so it'll be this part that we're looking at. And notice all I did was kind of eliminated those zeros so we don't look at it. And so now we have 60 that'll be divided by 2. What's 60 divided by 2?
30.
30. So it'll actually be 30 times 30. So write them out like we normally would with the zeros behind. Cross out all those zeros that they have in common. And then what we're left with will pretty much be what we determine the comparisons. Any questions about it?
No,
No, ma'am.
Everybody got what you need?
Yes.
You all are doing awesome this morning. When this afternoon. All right, this one says last year a business earned 4.1 times 10 to the $6 in income. This year the business earned 2.05 times 10 to the $8 in income. Which best describes how this year's earnings compared to last year? All right, once again, we're doing some comparison. So it would be best to go ahead and write out those numbers. So 1, 2, 3, 4, 5, 6. That shift right. 1, 2, 3, 4, 5, 6, 7. Then go back and put my comma. And then for the second one. 1, 2, 3, 4, 5, 6, 7, 8.
Split it.
yeah.
So now we have 4,100,000 and then 205 million.
Divide 41 and 205.
All right, since the 205 is greater, Jamal, that's the one you will be divided. So let me rewrite it. So it'll be that amount divided by this amount. And we can kind of follow what we just did in the last problem. Go ahead and eliminate these zeros that are the same. And so now we're left with 41 being divided by about 2,000. Or in other words, 2,000 being divided by 40. 4 times what would get us 20?
5.
Good job, 5. We got 1 zero in common. Get rid of 1, we left with 1. So that would be about 50 times large. And I hope I didn't lose you.
I got C.
Me catch it. I thought it was gonna be 5 instead of 50.
I missed some of that, Ken. It sounded like you was going in and out.
Oh, Kiriana was saying something.
Go ahead, Mitch.
So this was an estimate.
Yes. So when they pretty much ask you about how many times, yes, it'll pretty much be an estimate. And so that's how that's how I took off the 41 and just went to 40 instead of 2050. I just left it as 2000. So when you start to estimate, think about those numbers that you can multiply to get something else. I pretty much know 4 times 5 will give me 20. So that's why I estimated with them too. Good question. Kennedy, did we answer what you had a question about or what you mentioned?
Oh, I had said I thought it was gonna be 5 because I forgot we had to add the 0.
Okay. So definitely make sure you pay attention to that as well. All right, so today we did some scientific notation, right numbers in scientific notation, then we took them out of scientific notation and did some comparisons. I hope you did learn something. It wasn't much, but I hope you did learn something. And it's Monday, so I hope you have a great Monday. See you later.
You too.
See.
See you later.
Uh,
See you later.
Bye, Miss Catches.
Bye.